Assalamualaikum warahmatullahi wabarakatuh. Okay, you can comment in the Q&A box if you have any question. If you have any question, you can comment directly, okay, in the Q&A live box. So in today's lesson, we are going to analyze frame. Okay, frame using using flexibility method. Using flexibility method. Okay, I believe you can listen to me. So, okay, frame. So flexibility method we use to analyze indeterminate structures, beam, frame, truss, composite structure, as well as cable and arches. Okay, so this one we are focusing on frame. So this frame, if we look at the diagram, so this frame has two pin support. This frame has two pin support at A, pin support at B. Okay, and there is a uniformly distributed load. There is a uniformly distributed load located at the center of the beam. Okay, the beam 5 meter from the end. Okay, so the rigid joint, from the rigid joint. So AB has been labeled at the support, and we have to continue to label this frame because by looking at this frame, we have to analyze how many section do we need to have. Okay, so column, so let's say, okay, AB has been put into this diagram, so we have to continue to put another name, okay, to represent joint. It is C. Okay, it is C. And then D here, E, and F. So total total nodes that we have, okay, are 6. A, B, C, D, E, F. Okay, so we will have 1, 2, 3, 4, 5 cutting section. 5 cutting section. And by looking at the diagram, okay, degree of indeterminacy equivalent to, okay, wait. The first, this is equal to 1, should be 1. Okay, typo. Okay. First degree of indeterminacy. First degree of indeterminacy represent redundant equivalent to 1. Okay, calculate reaction. Calculate reaction. Okay, we know that there are 4 unknown reaction. There are 4 unknown reaction, and only 3 can be solved using equilibrium equation. So that is why we know that redundant is 1. And this one, okay, a redundant value need to be determined first. Then only we can determine reaction, the remaining reaction, 3 remaining reaction. So 1 redundant in this frame, okay, we have to determine using compatibility equation. And compatibility equation is also called as flexibility equation. Okay, so let's say I want to choose. Okay, remember, if it is pin support, we have to remove 1 from pin. Okay, let's say we remove BX. Okay, we remove BX. So what happened is BX is equal to redundant. So we write the compatibility equation directly. It is delta 1 node plus F11 times redundant BX, which is equivalent to 0 unless there is a support displacement at position B. So this will be the equation. This is the equation. Okay, the equation. So from this, so we can use label 1 because we're referring to this. Okay, 1, 1. Okay, the first notation, as I mentioned, always refers to the position. And second notation refers to type of beam. Okay, so from this we know that there are two displacement. One is come from primary system and another one is come from redundant system. And both of these are determinate frame. Okay, so we will analyze. Moment. We will analyze moment equation from the first system, primary system, and from the second system is redundant system. Okay, so we have to have the primary frame. So in primary frame, in order to write the moment equation, what we have is, okay, this diagram. This is determinate frame. This is stable frame. Okay, this is the support. The support at B change from pin to roller because we have removed BX. So having this, we can calculate reaction at the support, and after that we can write the moment equation. Okay, we can write the moment equation. For redundant frame is actually redundant BY applied, BX applied, BX is subjected into the system. Okay, assume as an applied load. So this is redundant number 1. Okay, so we label as M1. Okay, so due to a unit value of Bx, we have to calculate the reaction. So we get Ax is equivalent to 1, and we get Ay and Ay and dy equivalent to 0 because they need to balance. Okay. So dah ada dua-dua diagram ni. What we need to do is we have to write moment equation from primary frame and moment equation from redundant frame. Remember, we have 5 cutting section and I have actually labeled 1 to 5 in the diagram. 1 to 5 in the diagram like this. I label AC as section number 1, anti section number 5. Okay, and then for the redundant diagram also has the same cutting section from 1 until 5. Okay, so what I want is the moment equation. Anyway, you can write moment equation. So this one is how we calculate moment equation. Okay, the one that you have learned under 424 structural analysis. Okay, so we determine M naught for each of the section. Okay, for section number 1, section number 2, section number 3. Okay, remember origin will be okay, or the origin and the limit in the diagram. So this is for number 4, section number 4. This is for section number 5. Okay, settle primary frame. We move to redundant frame. Okay, in redundant frame, what we want is M. We want M1. Okay, this is M1. Okay, M1. So again, we have 5 section. Okay, so we have 1 here, 2, 3, 4, and 5. So we have 5 cutting section. So all the moment equation. So what most important is this table. The moment equation we tabulate into the table. Okay, so we have 5 cutting section, 5 section here, and then origin. Okay, put the right origin representing the right equation. Okay, because different origin may produce different equation. Okay, so this is for M naught for primary, M naught for primary. This is for primary frame. And M1 is for redundant frame. For redundant frame. So all this, from this, we just need to substitute into the formula. Substitute into the formula. So, okay, we can do it directly. Just put the value. Okay, we just need to put the value. We have delta 1 node. Delta 1 node, so AC and SB. Okay, we don't need to consider because we time with 0, we get 0. We get 0. So we integrate CD, DE, and EF. CD, DE, and EF. Okay, so for CD we have to integrate 200x times 5 from 0 to 5. Okay, what we get is 12,500. That is for CD. Okay, now we calculate for DE. We calculate for DE. 200x minus 20 x minus 5. Okay, times 5. From 5 to 50. So what we get is 66666.667. So this one, point 667. Okay, this is for DE. So move to the next one. It is 200x times 5. Okay, we get back the same answer. Is positive in this case. Okay, so the answer for delta 1 node, okay, for delta 1 node is equal to it is 9 91,666.667 is delta 1 node. Delta 1 node. Okay, move. Okay, then okay, next one is F11. F11, refer back to the table. Okay, refer back to the table. So it is okay, the first value is 41.667. 41.667. M1 square, this is for redundant. This is for redundant. The next value is 125. It is 250. And then 125. Okay, so it is 41.667. So the answer, so this one divide by EI. Okay, the answer is 583.334. It's 583.334. So we substitute this. Into compatibility equation. And in terms of EI, okay, this one times with BX. BX. Equal to 0. Equal to 0. So we get BY, BX. BX equal to, it is negative 91666.667 divided by 583.334. This one is 91666.667. We divide by 683.336. 583. 583.334. It is 1 negative 157.143 kilonewton. Okay, you should do like this as well. Okay, you should do like this as well. So it is actually simple step to analyze this flexibility matrix problem. Okay, what most important, will we will analyze redundant using compatibility equation. So in the compatibility equation, we have two displacement, and this displacement is come from moment equation. Moment equation, and moment equation, we want, when we want to write moment equation, we have to have reaction. So that is why we analyze primary frame, we analyze redundant frame, we start with calculating reaction and then followed by moment equation, because the moment equation we will substitute into the formula, and then we get the, okay, by substituting the displacement into the compatibility equation, we get Bx value. So this is the redundant value. This is the redundant value. This is the redundant value. So what we need to do after this is we will continue to calculate remaining reaction. Continue to calculate remaining reaction using, okay, we can have principle of superposition or superposition method. So let's say doing using superposition method. Okay. So to calculate AY, AY is equal to 200. Keep this one, 200. It is 0. It is just 200. 200 kilonewton. Because 0 times redundant. Okay, for AY, AX. AX. Okay, AX in the primary system. Okay. No AX in the primary system, it is equal to 0. AX in redundant system, it is -1. It is -1. Okay, it is -1 times with redundant. Times with -157.142. So what we get is positive 157.142 kilonewton. Okay, and then we continue the same process until we get the 3 remaining reactions. So this is how we analyze frame using flexibility method. Using flexibility method. Okay, let's try another frame example. Okay, I prefer to use this one again, but I want to add another loads. Okay, so let's say this is the same type of frame. In this case, I would like to add a horizontal load. Ini. And I want to add moment. Okay, so we label as A, B, C. Allah. So this is C, this is D, this is E, and F. And F. So to analyze this, what we have. Okay, let's say AX is chosen as redundant. So redundant AX. So having this, we will have delta 1 naught plus F11 times AX equivalent to 0. Okay, so from this we know that we have two systems. We have two systems. One is called as primary frame. And in the primary frame, we are going to have M naught. To have M naught. So let's say we analyze this. Okay, so at C, we have 250 kilonewton only, horizontal force. So this one is 450 kilonewton meter. Okay, let's say this is the frame with additional horizontal load at position C and moment counterclockwise at position F. So what we need to do? So we have to calculate reaction at the support. So we have to calculate reaction. Of course, this will be equal to 250, right? This will be equal to 250. UDL is 40. UDL is 40. We still use the same distance, the same height, and we have moment 450. So this is 450. 450. Okay, so we want to calculate AY value and DY value. So by taking moment at position D, which is equal to 0, so we get AY times 20, because it is 20, yeah? AY times 20. Okay, we have to plus with 250 times 5. Okay, we get minus 40. 40 times 10 times, it is 10 meter, 5 plus 5, 10. Okay, the length from centroid, okay, to D. Okay, then we have negative 450 equivalent to 0. So we get AY equal to is 250 times 5 minus 450 divided by 20. It is 160. Okay, the rest can check whether this is correct answer or not. Okay, this is 160. So from this 160, okay, AY is 160. So this is 160. So dy is 40 times, it is 40 times 10. We minus by 160. It is 240. 240. Okay. So we calculate now the reaction in the redundant frame. In the redundant frame. So redundant AX applied. So this one we produce M1. Okay. So we have AX as redundant. This is 1. So we get 1 as well for dx. For dx, and this will be 0. Okay, we label A, C, D, E, F, B. Okay, this equals to 5. This is 5 meter, 5 meter, 10 meter, 5 meter, 5 meter. Okay, now we have 5, C, D, E, F. Okay, I want to label. So this is 1, this is 2. For the cutting section, this is 3. This is 4, this is 5. For the section 1, 2, 3, 4, 5. Okay, so moment equation I put into the table. So the table, okay, there are 5, 5, 6. So I want to insert table. Six. Member origin limit M0, M1. Okay, so this is member. This one is for member. Origin limit M0, M1. For member A, C, this is member number 1. For member number 1, what we get? Okay, the first moment equation, so ini origin A, limit 0 to 5. The value is equivalent to 0. The value is equivalent to 0 for the primary frame. For the primary frame. Okay, for redundant. So for redundant, what we get is like this. This is 1 moment anti-clockwise. So we have M, this is M, which is equivalent to negative X. So this one is negative X. Okay, we move to the second section. C. It is CD. It is CD. This one is CD. This is cutting section number 2. Origin. Okay, origin must be must be either C, D, E, or F, because X always move in straight line. So let's say A is the not A, it is C. It is C. Because X must move in straight line. So we choose C. CD, origin C, limit 0 to 5. So this one, what we get is this This is 160. We get like this. So x, where is x? As x is here. So what we get is m is equal to 160x. 160x. And then for M1, it is like this. This is 1. This is M. It is negative M, negative 1 times 5. So M is equivalent to negative 5. M is equivalent to negative 5. Okay, so let's look at cutting section number 3. Number 3 is DE. It is DE. This is number 3. Number 3. Okay, so I want to choose D as origin. I want to choose D as origin so that the limit will be 0 to 10. Because if origin is either D or E. So if member is D and DE. So by choosing origin, okay, one of D or E. Okay, limit will always start from 0. Okay, we always start from 0. Maybe the total length. Okay, so how about this cutting section? The cutting section, this is 160. This is A, B, not B, C. This is C, D. Okay, so what we have is this distance. There are 2. Okay, this is X, this is 5. So this is moment. This is moment. So we get negative M plus 165 plus X UDL. Okay, it is, this one is 40. This is minus 40 times X over 2. This is equal to 0. So M is equal to, it is 160 times 5. 160 times 5, we get 800 plus 160x minus 20x squared. It is 20x squared. Okay, 800. It is 800 plus 160x minus 20x squared. Okay, and for redundant diagram, for redundant diagram, what we have is this. This is 5. This is A, C, D. So the moment is like this. M minus 1 times 5. So still we get M is equal to negative 5. And then we have DEEF. EF as section number 4. Section number 4. For section number 4, EF origin is, this one is E. Origin is F. Origin is F. Okay, origin ni paling senang. Sebenarnya origin, bila we write moment equation, paling senang kita ambil kalau EF. Member dia EF. So paling senang ambil either E or F as origin. E or F. Yang mana whenever kita pilih antara dua tu jadi origin, automatic limit dia akan start from 0. So in this case 0 to 5 lah. Length dia 5 meter, so dia 0 to 5. So macam mana section dia? Section untuk yang tu. Yang ni Okay, we have 450. We have 450. Okay. Origin from right. From right. Moment clockwise. So this is M. 450 counterclockwise. 450 counterclockwise. So we have dy 240. dy sini 240. And we have 250. 250 reaction. 250. Okay. So this is B, F, E somewhere here. So we want E, F. So origin we choose F. Origin we choose S means X start from F. Okay. Like this. Okay, so we write equation. It is M minus 450 minus 240 times X plus 250 times 5. This is equal to 0. So M equal to it is 1700. It is M plus 1700 minus 240 X equal 0. So M equal to 240X minus 1700. So 240X minus 1700. 240X minus 1700. Okay, for the redundant diagram, what we have for EF? So what we have is moment plus 1 times 5 equal to 0, M equal to negative 5. Okay, the last cutting section is FB, origin B. This is number 5, 0 to 5, 0 to 5, and the equation. For the equation, it is 250. It is 250 here, 240 moment. So what we get is M plus 250 times X equal to 0. So M is equal to negative 250X. Negative 250X. And for redundant diagram, it is just simple one like this. This is the moment. This is 1. So what we get is negative X. Negative X. So these are all the moment equation. Moment equation. So from this, we will calculate as usual. Okay, we can continue to calculate compatibility equation. It is delta 1 naught plus F11 times with AX. AX which is equivalent to 0. So there are two displacement, 1 over EI from 0 to L M1 M naught dx, and F11 equal to 1 over EI from 0 to L M1 square dx. Okay, so simple lah, dia macam yang previous exercise. I just add horizontal load and moment. Okay, so we can continue to calculate delta 1 naught. So delta 1 naught, we do integration. Okay, so what is the answer? So it is delta 1 naught equal to negative 10,000 for the second, because for the first value it is 0. Okay, then we integrate. Okay, it is equal to negative 46. So this is negative 46667. 46667.667. And is 240x minus 1700 times with negative 5 from 0 to 5. 27,500. 27,500. Okay, so this one divided by EI. So this equal to okay, you can check back the answer whether it is correct answer or not. Okay, but this is the procedure lah. 166.667 over EI. And F11 equal to F11. F11 I think equal to the previous one. Not exactly, because DE is different. Okay, not exactly because DE is different. So we have to key in the value into the calculator. Okay, it is negative X. Okay, we continue one by one. Okay. So what is the answer? Okay, the first value is 41.667. 41.667. The second value will be 125. The third, okay, the third section, 0 to 10. It is 250 plus 125 plus 41.667. 41.667 plus 125 plus 250 plus 125 plus 41.667 EI. It is 583.334 over EI. So then we substitute into the compatibility equation. So it is negative 291.667. 29166. Negative 29166.667 over EI plus with 583.334 divided by EI times with AX equal to 0. So what we get, solve this to get AX, which is equal to 29166.667 divided by 583.334. Then we get the AX value. So it is equal to 0.05. 0.05. Okay, can check back the answer. Okay, memang you have to do a lot of exercise because by doing this, especially moment equation tu, especially for the moment equation, ramai yang akan buat banyak careless mistake. So kena double check the equation, double check the displacement, betul tak the equation that you put into calculator, tekan calculator betul ke tak betul kan. So akan affect semualah. But basically kalau you boleh bagi macam ni, even though the answer is wrong, tapi by when I look at your okay, answer script. Okay, answer script. Saya tengok ada tak kat sini redundant? Ada. Correct redundant, correct redundant. Ada tak the equation? The compatibility equation. Okay, ada dekat sini. Okay, and ada tak primary system? In the primary system ada reaction. What is the reaction? Okay, and then ada redundant system. Redundant system, do you put the right redundant? And then ada tak reaction? And then all moment equation. Okay, in the table, and then from the moment equation in the table, continue to calculate the value of displacement and then substitute into the compatibility equation. Then when you solve, you solve the redundant value. You solve the redundant value. So this is not the end of analysis, but this is the procedure that we apply to all type of structure. Tak kisahlah dia beam ke, dia frame ke, dia truss ke, sama je proses. Except kalau truss tu dia pakai different formula, because in truss kita consider member forces as internal forces, tak macam beam. Beam and frame we have to integrate moment equation to get displacement. Two moment equation to get displacement. Okay, basically kalau you can give this for your test, for your assessment, okay, all step is like this, then you should be able, you can score for your assessment. Okay, so yang ni je lah. So lepas tu boleh continue sama macam step tadi, the same one, sama macam step tadi. So continue to calculate remaining reaction. Continue to calculate remaining reaction. Okay, we have A, Y, dy, dx. Calculate. Then baru consider siap. Okay, baru consider siap. Kalau ada soalan lagi, additional question, suruh you draw shear force diagram, so you just need to continue. Okay, so this is frame with one redundant. Frame with one redundant. So you can consider also frame with two redundant. So for frame with two redundant, let's say we have this. Okay, I just want to highlight the procedure. Okay, for frame with two redundant. So two redundant, we have this. Okay, let's say we have only this. Okay, this is fixed, this is pin. Okay. So I have here macam ni. Point load. Okay, so this is A, this is B, this is C and D. Okay, so yang ni 10 meter, yang ni 4 meter, yang ni 5 meter. UDL is 50 kilonewton per meter. Point load is 350 kilonewton. Okay, so when we have this, we have to identify DOI, which is equivalent to 2. Okay, this is redundant. Okay, this is redundant. Okay, there are two redundant. So we must choose two redundant to remove from this system. So we have R1 and R2. So decide the best redundant option so that the frame will remain stable and determinate. Okay, let's say we remove one from A, so remove MA. So fix, when we want to remove one, we remove MA. Moment remove dulu. Tak boleh remove pin dulu, tak boleh remove vertical force dulu, tak boleh remove horizontal force dulu. Mesti remove moment dulu, so that frame, so that fix tu, bila remove satu, dia jadi pin. Okay, yang ni kita letak DX. For example, boleh juga letak AX, so we remove 2 from A. Mana-manalah, because bila kita ada 2 redundant, we have 3 possible primary structure. Okay, and then from this we know that the compatibility equation, which will guide us what step to do, is this equation. It is theta 1 naught, delta 2 naught, plus F11, F12, F21, F22 kali dengan MA and DX equal to 0. So from this, we know that the moment equation that we want, okay, moment equation that we want is 0, 1, and 2. So we want moment equation which come from 3 system. It is primary system M naught, redundant number 1 R1, redundant number 2 R2. Okay, so from this, what we want is, because we know that we have to integrate moment equation to calculate displacement. So what we actually want is M naught, M1, M2. So this is come from primary frame. M1, this is for redundant, MA applied. And M2 is redundant DX applied. Okay, so we have 3 system like this. So this become pin now, this become roller. Become pin, become roller. So this is A, B, C, D. Okay. This is for M, not. For M1, same support, same label, but this is subjected to a unit value of moment. Then we have to calculate reaction and write moment equation. Okay, this is M2. And then for M3, so for M3 we have same support, same label. Okay, this determinate frame is subjected to a unit value of redundant. A unit value of redundant. So this, analyzing this, the moment equation for this is not 2, this is 1. Okay, equal to M, this is M2. And then, dah dapat the moment equation. Okay, tabulate in the table form. In the table form. So, in this case, table, dia punya table is look like this. Member, origin, limit, M, not M1, M2. Okay, we have A, B, B, C, C, D. Okay, so this one is origin A, origin D, and origin. Okay, BC, BC, mana BC? Okay, BC can be B as origin, can be C as origin. Let's say I want to choose can be B as origin. Okay, so limit dia as I mentioned just now, bila nak letak limit, AB origin tu either A or either B, limit dia mesti start dengan 0. Sama juga BC, bila origin dia either B or either C, limit dia mesti letak start dengan 0. And for CD, if D tu, origin tu D, so D tu part of C dengan D, dekat situ either one of that. So ini start dengan 0. So 0 to member length. Member length A to B. A to B tu 10 meter. So ini jadi 10. B dengan C, jarak BC. Distance BC berapa? BC 4 meter. 4 meter and 5 meter. So this is 4 meter. C dengan D, origin D, this is 5 meter. So having this, you just need to substitute all the moment equation into this table. And finally, dah ada all the moment equation in the table. You need to substitute into the displacement formula, dapat displacement, lepas tu masuk dalam compatibility equation, lepas tu continue to calculate remaining reaction. Okay, lepas ni nak buat apa? Number 1, calculate displacement, 6 displacement. Calculate 6 displacement, lepas tu write compatibility equation. Okay, write compatibility equation and then solve. Solve dapat redundant. Redundant, dua-dua redundant tu. And then finally, kena apply either principle of superposition or equilibrium equation. Equilibrium equation to calculate remaining reaction. So this is remaining reaction. 3 lah. 3 remaining reaction. Okay, so dah dapat ni, dah settle lah. Kita dah calculate all displacement. All reaction. Reaction at the support. Reaction at the support for this frame. For this frame. And then, sometimes ada soalan yang minta you continue untuk calculate deflection. Sometimes akan ada extra question minta you draw shear force and bending moment diagram. Okay, so this is how we analyze frame. Sama je, basically frame ni kan dia sama. Okay, frame ni some has similar analysis with, okay, frame ni has similar analysis with beam. Okay, similar analysis with beam, frame. Okay, frame ni ada similar analysis dengan beam. So kalau you dah boleh analyze beam, you boleh analyze frame as well. Kalau you boleh analyze beam, you boleh analyze frame as well. Okay, cuma flexibility method ni konsep dia I believe bila dah gone through few weeks, so every student akan faham what is flexibility method. Even though dekat banyak buku, banyak cara, bukan banyak cara lah, macam the way dia treat the redundant system tu mungkin beza, tapi what I give to you is the simplest way, because kita pakai F, kita tak pakai delta. Kalau you pakai delta tu dia lain, you kena, bila you nak tulis equation tu, you kena tambah additional dalam equation tu. Okay, tapi kalau you pakai yang apa yang saya tunjukkan ni, okay, apa yang saya share, so kita dah actually belajar deriving compatibility equation from principle of superposition. Okay, kita take out redundant tu. So bila kita analyze, kita just analyze two system for one redundant. So the two system that we analyze to, it is just like we analyze real system and virtual system masa you belajar topik unit load method. It is just like. Tetapi yang ni a unit value tu, not only a unit value of a unit value ataupun virtual force, tetapi it is a unit value of redundant. A unit value of redundant. So equation kita displacement kita pakai semua simbol F. So tak payah pakai simbol delta BB. Sebab apa? Ada dalam, kalau you rasa confused kan, kalau you tengok nota, dia buat macam ni. Dia buat delta B0 plus delta BB equal to delta B. Betul, this is the right one. But delta BB is actually equal to FBB kali BY. Okay, that is why bila kita tulis, kita just tulis delta B0 plus FBB kali dengan BY equal to 0. That is why bila you nak cari displacement for displacement F, tak payah pakai simbol delta ni. Jangan pakai simbol delta untuk cari 1 to 1 to 1 to 2. Jangan pakai simbol ni. Because bila you pakai simbol ni untuk cari displacement in redundant system, yang ni dia datang dengan package ni. Maksudnya lepas you tulis formula 1 you tulis formula 1 over EI, yang ni kan, you kena kali dia dengan redundant tu. Ni kita tak nak. That's why saya dah mudahkan supaya you tak perlu tulis delta ni, tulis F. So displacement in redundant system semua kita pakai F. So bila kita tulis F, kita tulis macam biasa kita buat. Okay, macam biasa kita buat FBB is equal to 1 over EI. Okay, 0 to L MB dx. Okay, so sebab tu bila dalam lecture saya tak akan ambil soalan dalam lecture notes untuk explain. So soalan-soalan dalam tu you boleh refer soalan dan jawapan. Betul, tetapi kita pakai yang ni. Okay, kita pakai yang ni. Kita tak pakai yang ni. Kita dah derive. Whenever we derive, kita dah take up redundant tu. We have take up redundant forces outside. So bila kita analyze, we just analyze due to a unit value. Okay, due to a unit value. Different books may have slightly different. Okay, cara dia explain solution. Tetapi, so I hope that you follow what I deliver to you. Okay, so this is the equation that we use to calculate the redundant, and F, okay, the symbol F can be represent displacement, can be represent rotation. Okay, and what is F? This F is flexibility coefficient. Okay, you can choose any question that you like. You can choose question from textbook. You can use question from other notes. Okay, notes yang ada dalam island tu saya pun dah letak kat situ. Tapi yang tu actually made by Shah Alam teams. So, diorang pakai yang saya cakap situ lah. Pakai yang ni tadi. Okay, pakai yang ni tadi. So, bila tak pakai yang ni, dia ada additional lah. Dia ada additional. Okay, lepas ni kita akan masuk trust analysis. In trust analysis, dia ada effect. Kalau beam dengan frame, dia punya effect is support settlement. Support settlement yang normally kita discuss dalam beam and frame. Okay, and for trust analysis, kita akan tengok effect of fabrication error and temperature changes. Effect of fabrication error and temperature changes. Okay, and of course, kita akan try to relate back dengan basic concept. Dengan basic concept of displacement. Displacement yang you dah pernah belajar dalam unit load method. Okay, so that's all. So that's all I want to discuss in this session. So tomorrow nanti saya bagi time because tomorrow saya ada kelas dengan Shah Alam. Saya buat extra class juga dengan Shah Alam. So I will tell you later what time we will continue to analyze trust. Okay, so tiga-tiga ni including composite structure. So all are very important. Even though satu je masuk test tapi ada possibility lagi bukan possibility. Ada satu lagi soalan akan masuk final exam because kita dah balik kepada syllabus before pandemic. Okay, syllabus before pandemic. Syllabus before COVID. Okay, so practice a lot. Okay, thank you very much. We will meet again in the next video. Assalamualaikum warahmatullahi wabarakatuh.